Hydrogen fuel cells are a promising technology that has the potential to revolutionize the way we generate and use energy. They are efficient, clean, and versatile, and can be used to power a wide range of applications. There are several types of hydrogen fuel cells, each with their own unique characteristics and advantages. Proton exchange membrane fuel cell, PEMF. The PEMF is the most common type of fuel cell and is used in a wide range of applications, from small portable devices to large vehicles and power plants. It operates at a relatively low temperature, around 80 degrees Celsius, and uses a polymer electrolyte membrane to transport protons from the anode to the cathode. The cathode is typically made of platinum, which acts as a catalyst to speed up the reaction between hydrogen and oxygen. The PEMF is highly efficient, with an efficiency of up to 60%. Alkaline fuel cell, AFF, was one of the first types of fuel cells to be developed and is still used in some specialized applications, such as space missions. It uses an alkaline electrolyte, usually potassium hydroxide, and operates at a higher temperature, around 60 to 90 degrees Celsius, than the PEMF. The AFF is highly efficient, with an efficiency of up to 70%, but it is not as durable as other types of fuel cells. Solid oxide fuel cell, SOF. The SOF operates at a much higher temperature, around 800 to 1000 degrees Celsius, than other fuel cells. Also, it uses a solid oxide electrolyte, usually yttria stabilized zirconia, to transport oxygen ions from the cathode to the anode. The anode is typically made of nickel and operates as a catalyst for the reaction between hydrogen and oxygen. The SOF is highly efficient, with an efficiency of up to 60%, and can be used in applications that require both electricity and heat. Direct methanol fuel cell, DMFC. The DMFC is similar to the PEMF but uses methanol as the fuel instead of hydrogen. It operates at a relatively low temperature, around 60 to 90 degrees Celsius, and uses a polymer electrolyte membrane to transport protons from the anode to the cathode. The cathode is typically made of platinum, which acts as a catalyst to speed up the reaction between methanol and oxygen. The DMFC is highly efficient, with an efficiency of up to 40%, but it is not as widely used as other types of fuel cells. Phosphoric acid fuel cell, PUF. The PUF uses a phosphoric acid electrolyte and operates at a relatively high temperature, around 150 to 200 degrees Celsius. The anode is typically made of graphite, and the cathode is usually made of platinum. The PUF is highly efficient, with an efficiency of up to 50%, and is commonly used in stationary power plants. Each type of fuel cell has its own unique advantages and disadvantages, and the choice of fuel cell depends on the specific application and requirements. However, all fuel cells share the same basic principle of converting hydrogen, or methanol, into electricity, heat, and water through an electrochemical reaction. As technology continues to improve, fuel cells are likely to become an increasingly important source of clean, efficient, and sustainable energy.